that's called the mass spectrometer. 3 things really you need to know about the mass spectrometer. You need to know the principle, which is like one sentence explaining how the instrument works. You need to know 5 processes or stages or steps, I suppose, in what happens in the instrument. And then you also need to know the applications, the uses of the instrument. So remember yesterday I showed you a mass spectrum for mercury, and you were supposed to work out the relative atomic mass for an atom of mercury, the average mass of one atom of mercury, taking the abundance of the isotopes into account. Well, that mass spectrum is what you would get. That's the printout, if you like, that you'd get from this instrument called the mass spectrometer. So the principle behind the mass spectrometer, I'm just going to tell it to you now, and we'll see it again in a minute in the PowerPoint, is that charged particles moving in a magnetic field will experience a force, and the size of the force that they experience depends on their mass. So they're separated, the particles are separated on the basis of their mass, and that's why the instrument is called a mass spectrometer. Now, let's just run through the stages nextly, I suppose. Now, the other thing I just wanted to remind you of was, remember when we were doing our chapter 10 on gases, and the experiment that you used with the propanone, remember you were asked to find the relative molecular mass of a volatile liquid. Now, you were able to use that method when we were doing that chapter because acetone is a volatile liquid. It has a low boiling point and it evaporates very easily. You would use a mass spectrometer to find the relative molecular mass of things that were not volatile, so non-volatile. If they ask you non-volatile liquids or solids, you see. So you could use those kind of samples in a mass spec, whereas a volatile liquid like acetone, then you can measure the relative molecular mass of that using the experiment that we did in school. So first stage, so anyway, look, is vaporization. So vaporization means basically you're turning your sample into a gas. So if your sample is a solid, you have to melt it first. If it's a liquid, then you inject it straight in. And when it goes in there, the sample is converted to a gas. So very, very low pressure chamber, and the liquid that goes in, because of the low pressure, the molecules turn into gas. And then the second stage is ionization. So vaporization is step 1. And then in ionization, you see you have an electron gun here, which does exactly what it kind of states. It fires electrons out of the filament. And those electrons kind of bombard the atoms or the molecules, knocking off the outer electrons from the atoms. And therefore, you're going to form positively charged ions. So ionization means that you form positively charged ions by knocking electrons off of the outer shells of the atoms. You have a negative plate here. You see this negative plate? So the positively charged ions that you form in the ionization chamber are accelerated towards that negative plate, because unlike charges will attract. And there's one little slit, if you like, in that plate there, look. So you get one single beam of ions coming through the slit. Okay, so they're accelerated. The positively charged ions that are formed in ionization are accelerated towards the negatively charged plate. And one single beam of these ions pass through a hole in the negative plate. Okay, this huge electromagnet, now look here, is creating a magnetic field. And what happens then is the single beam of ions, as it moves through the magnetic field, those ions experience a force as they're traveling through the magnetic field. The size of the force that the ions experience depend on their mass. So the heavier ions wouldn't be deflected as much. They kind of stick to their path. The lighter ions are deflected more, look. And then the detection of those ions is recorded there and amplified. And this is what you get at the end. You get your mass spectrum at the end, okay? And remember, just finished with that now. So do you remember that's what the mass spectrum then would look like? Okay, now I just want to run back to the PowerPoint here for a second, and in the PowerPoint here, look, we can just run through what I used the diagram for. So the mass spectrometer, the principle: charged particles moving in a magnetic field experience a force or a deflection, and the size of that force depends on its mass. Stage 1, vaporization: small amount of the gas or the liquid is injected into the mass spec. Very, very good vacuum, so practically an empty space, and the liquid turns to gas. So that's vaporization. Ionization: the electron gun that I showed you in the diagram knocks off electrons from the outer shells of the atoms, and therefore you form positively charged ions. Those positively charged ions are accelerated towards the negative plate, and remember we said there was a little slit in the negative plate, and the single beam of ions pass through that plate. How are those ions separated? They're separated according to their mass as they travel through a magnetic field. The lighter ions are deflected more than the heavier ones. And then finally, detection, where the beams are passed through a machine and detected electrically. There's your diagram again. And that's it in a sort of a 3D structure. Now, applications or uses of the mass spectrometer. What were we able to do with the mass spectrum that I gave you yesterday? You were able to identify the presence of isotopes. You knew that there were 6 isotopes of mercury. You were able to read off the y-axis the abundance of each isotope. Then you were able to calculate the relative atomic mass. Okay, and you emailed me the relative atomic mass of the mercury atom. And in college, you would be able to work out relative molecular masses. That's outside the realm of our course, but you could calculate relative molecular masses. And the fourth thing that you can use a mass spec for is to identify unknown compounds. So like if you were drug testing or analysing gases from waste dumps or something like that, you'd use the mass spec for that as well. Okay? Now, just finally, I just want to run through on the show me board there. We use Victor is a stupid dope. Now, how is Victor is a stupid dope going to help you? It'll help you with the 5 stages or processes that occur in a mass spec. So the first one, remember, was vaporization. Ionization means you're turning the atoms into positively charged ions. Acceleration towards the negative plate. Separation occurs in the magnetic field. You must say in a magnetic field there. And then finally, dope for detection. Okay, so that should hopefully help you